Friends, after a long time, due to unavoidable situations, I'm just trying to extend my help through online video lecturing. So I guess from this particular slide we need to continue our class. So previously we are discussing about the group technology and production flow analysis. So in that we already discussed what is part families and how we are going to divide them for grouping into a cell or used for combination of this flexible manufacturing systems. So in this video we are going to see how this production flow analysis is going to help in mass production and making the manufacturing system little bit fluid and processed very smoothly. And here we are seeing what is production flow analysis. So it is a method for identifying the part families. The part families, as you know earlier, it is depends on the design or the process which are having similarities. We are going to divide them or separate them based on these two parameters. So they depends on the particular application, we are going to divide them as part families and associated mission groupings based on what exactly that mission or the component requires, on which mission it should process the particular manufacturing process. Depends on that particular thing, we are going to decide the production route sheets. Route sheets are nothing but one component. For getting into a product, it should go through number of manufacturing machines which requires drilling, which may requires upon drilling, it may going on tapping or other milling process. So different machines need to process for getting into a final product. So all these particular groupings based on different route sheets rather than part design data. Part design data is nothing but we already did in the previous classes. We are not moving this particular production flow based on only design. We are moving that particular element or the route sheet based on the uh, mission through which it is going to takes place, like the processing mission which is going to contribute the particular machining process. So based on that and keeping aside the design data, we are moving the production flow of that particular material or the component. So here the work parts with the identical or similar route sheets are classified into part families. So keeping the design data aside, we are only concentrating on the route sheets or the like particular route an element or a particular workpiece or the final product is followed to get into that particular shape is considered. So advantage of this route sheets, we know parts with different geometry may require similar processing or same processing, which is it is telling that like even the geometries of the particular parts are different. So some particular part families may require the same machining process, even the design data is different. Suppose let us say if you are manufacturing a gear, so a simple spur gear, a helical gear, or else like a bevel gear, all require some milling operations but with the same particular machine. So there the design data is different but the same operating or the operation of the particular manufacturing process on the machine is same. So particularly that particular thing will be used in this route sheet data, and combining all such particular machining process, we are going ahead and parts with nearly same geometries. As I said before, those we consider we may have a similar geometric properties or else like having the same processes or machining processes. So those we are considered into one group and we are going ahead for production flow analysis. And going to the next, these are the steps needs to be followed for production flow analysis. One is the data collection. The data collection is nothing but the sequence of the operation or the manufacturing process which may be used for dividing them, or the next in the next process you can see the sortation of process routings where you are sorting that particular element through the data collection. We already have data and with that data we are dividing them or sorting them based on the process route or just like the flow of that particular process on which the manufacturing process is going on, based on the design, based on the manufacturing machine similarities or the similar design similarities. And next to that, we are having the PFA chart, production flow analysis chart, which is displayed with the part mission index matrix, where we can see whether that particular chart is having the use of machining or not with the 1 or 0, which is a binary format, and we'll see how it is represented in the chart. And this is a very much important or very important chart in production flow analysis. And next to that, after having or attaining that particular chart with the above two steps, which is data collection of the elements and sortation of the process routings, and after getting the each individual matrix of these charts, we are going to have apply the cluster analysis using some algorithm. So here what we are doing, we are making the charts combined, and we are making the clustering thing, where we are going to display this process into clusters, so similar routings which are having the same roots, and each mission group we are dividing that into a mission group, which is nothing but we call it as a mission shell. So here you can see, one taking an example, there are different missions over here and different parts over here. As we discussed, now we are talking about the parts where it requires different missioning to be carried out. So if we consider the mission A, or the part A, sorry, this is for part, the rows over here is nothing but parts, and the columns over here, these are the missions. So the first part A, which requires the mission A as well as the mission 5. The part A requires the mission 1 and the mission 5. As randomly you can consider the part F, which consider the mission which requires the missioning process from mission 4 and even the mission 7. So this is the chart what we got initially. Now after considering what we'll do, we will apply the rank clustering or the production flow analysis on this particular chart, where after doing data collection and sortation, we used to get this production flow chart of different elements and different machines which requires the similar process for machining processes. So here we have, as you can see here, I have divided the parts. The machines 1 will have 3 parts which are ADH. Just for your rough idea, I have did this. So anyway, after going through ahead, we will be discussing how this sortation and rank clustering algorithm we work. Normally that we call as King's algorithm. So here I have, first what I did, I have divided row wise and column wise. So row wise you can see 1, 2, 3 missions. So for each mission, these are the parts which are assigned, and in the same way for each parts, these are the missions required for operation. So as you can see, for mission 1, this is mission 1, and we have A, which is A, and D, which is D, and H,